Welcome to session 4BB, the 4 innovation drivers for AppSec. Craig Hartwell and John Smith of Vericode are going to present. If you've got any questions, type them into the chat, and I've put the link to the feedback for the session in the chat as well. So Craig, John, have a good one.
Thank you very much. And nice to be back at this virtual GSE session. Not quite as fun as it is in being in person, but hopefully that's going to be rectified next year. Keen to introduce John as a first-time GSEer this year as well, and so we'll do a quick introduction. If we want to move to the next slide, John, we'll do some housekeeping rules. So obviously there's the charity raffle, which is always a highlight of the GSE event. Again, especially in person after a few days on site, but there is still that opportunity to give, and some of the supported charities there are being shown. So please feel free to log in and give generously in yet another virtual environment. But I think let's crack on, John, and do a bit more of a formal introduction to yourself. So John, please tell us about yourself and your role at Vericode.
Absolutely, thanks, Craig. Yeah, I'm John Smith, as the name suggests. I'm the EMEA CTO for Vericode, which is basically about leading the team of solution architects, actually covering EMEA and Asia Pacific, and helping our customers and our prospects to understand what it is we do, how we do it, and how it fits into their environment and how we can make it work for them. So really, that's what my current role is. I've been in information security for over 25 years now, and about 16 of those years have been very much dedicated to application security and the vulnerabilities and things that we find in software and helping organizations to fix them.
Brilliant, thank you, John. And had we been in a room full of people, I'm sure some of the GSE community would have recognized my black and white face, but I'm Craig Hartwell, recently joined the Vericode team to kind of help with the whole DevSecOps adoption movement, helping Vericode in their move towards that DevOps community. But that's kind of what I've been doing in the last 5 years with the mainframe community, and really helping with that adoption, spending a lot of time with CompuWare and its strategic accounts, and we today have the opportunity to really kind of to come and articulate what the hell does AppSec have to do with the mainframe, and given some of the experience that we've had and some of the experience and I guess opportunity moving forward, we're going to articulate some of that today. But if you do have questions, as Stuart said, please drop them in the chat as we go. We're going to look at some of the trends shaping the AppSec movement, as John alluded to. It is a well-trodden path with a huge portion of the industry now really taking it seriously, and so we're going to look at how that kind of plays out, and what are the 4 innovation drivers for AppSec as we see the immediate future in that world, and really how can Vericode help its customers today, and indeed yourselves. So strap in. It's going to be a exciting ride, isn't it, John?
Well, we can only hope.
So let's kick off.
Yeah, and I guess starting off with the question of what on earth does AppSec really have to do with the mainframe? I'll come clean. I am by no means a specialist in mainframe. I did spend some time working at IBM, and there's some necessary indoctrination you go through on System Z and all that means to the business. But I've never spent that much time in the world of the mainframe. So, when Craig and myself had the opportunity to talk here today, started doing a little bit of research, started doing a little bit of thinking, and the thing that obviously leaps out at you when you're in the AppSec space that I am is, all right, well, what programming languages do operate in the mainframe environment, and what does that mean in terms of security? And so, it becomes about COBOL. That's the entry point to this. So I started looking at security, application security for COBOL. And whilst there are different application security testing technologies, we have static analysis, where we look at the code and understand issues in the code. We have something called dynamic analysis, where we interact with a web front end to something, or a web interface, an HTTP interface, and we try and trigger issues through there. And then there's things like software composition analysis that uses looks at the open source components that you're using in your software and tries to identify known vulnerabilities that might exist in there. Well, not so much on the dynamic analysis when it comes to the mainframe, not so much on the open source components, certainly as relates to COBOL. But actually, static analysis is a perfectly valid and reasonable thing to do for COBOL, just as it is for any other programming language. You know, the principle behind it is that you look for where externally controlled data enters the flow of the program, the flow of the software. You look at how it flows, how it is passed through the software, and whether it reaches any dangerous methods, any dangerous activities. And so that applies just as much to COBOL as it does to Java or .NET or any of the sort of JavaScripty modern languages. So absolutely, static analysis is a thing for COBOL. You know, here on this slide, I've shown the different categories of flaws that Veracode tests for in COBOL code. And you'll see in there at the top of the list, the higher severity issues, things like command or argument injection, things like SQL injection, untrusted search paths, buffer issues, those kind of things. They're all potentially very serious and dangerous issues that can exist in COBOL software just as anything else. What I thought would be interesting would be to get a sense of, you know, where does that actually, what do we actually find? And, you know, one of the nice things about the way that Veracode operates as a software as a service business is that we have an anonymized database of a huge amount of information from all of the software that we've been testing over the years. So what I found was that 14% of all of the COBOL apps that we scanned, when we first scanned them, so effectively this is unscanned code, this is brand new, fresh code that's never been through a static analysis cycle, 14% of those had either a high or a very high severity flaw. I focused in on high and very high severity because that is often where organizations focus their effort, on the sort of upper end of the severity spectrum. Now, I did compare that to the general population. General population, we see more like 24% of applications having high or very high severity flaws. So it's absolutely true to say that it looks like COBOL, and I guess this is an artifact of the long life that this code probably has had. It tends to be well maintained, it tends to be fairly secure, but still we do find issues in there. So to me, that seemed like a pretty good argument for why AppSec was relevant to the mainframe. And then I spoke to Craig, and he pointed out that actually mainframes don't just run COBOL anymore. There's a lot more that goes on in the world of the mainframe. He pointed out that Linux on Z has been around for quite a long time. That's a continuing sort of evolution. And also that even, you know, what we think of as really modern cutting edge technology like Kubernetes, well, yeah, that's being run on the mainframe too. So there's absolutely a bunch of stuff that is AppSec relevant that operates in the mainframe environment. I won't embarrass myself by trying to go too much deeper into that, but I will, Craig, if I could call on you to sort of, you know, talk about your experience of this and how this relates to modern application security.
No, absolutely. I think it's a good segue to actually say hello to Atul and link that question is just raised around open source in general on the mainframe. And so with IBM announcing Red Hat OpenShift, you know, container provision on the mainframe a year or so ago, and talking to some of our tried and tested mainframe contacts over the last few years, you know, an awful lot of them are looking at some flavor of Linux and containerization on top of the mainframe. So the fact that the underlying hardware happens to be, you know, an IBM Z platform, you are still running open source, you're still running Linux, you're still running containers, and all of the various security flaws that come in and around that are very relevant. You know, the fact that it happens to be running on Z underlying technology is kind of irrelevant at the application layer. And as IBM has changed and looked at ways of trying to embrace the next generation of developers and what have you, and actually change their licensing models such that dev and test on Linux, on Z, can actually in effect be cost effective, as in zero, for those that have invested on the mainframe platform, then a lot of the financial services accounts that we've been working with are really analyzing, can they use this as the platform that is 6 nines available? It's in the basement of their organization, so inside their own 4 walls. So they get all the functionality and the security of, increased security even than like a public cloud service, but it's inside their own boundaries. And from a legislation perspective, there are still a lot of banks in the European sector that really need that capability. So this really does open up the mainframe platform as a first-rate citizen. As I say, we've worked with customers over the years to actually bring the mainframe into the DevOps tool chain. Now, something like containerization and Kubernetes sitting on top of mainframe really just then expands the need for solid security testing on those applications that sits on top of the mainframe.
Excellent. So hopefully that means that you're still listening and you are convinced that there is something to be done about application security in the mainframe environment. So if we take it from that position, one of the things that we as Veracode have to think about is, what is the direction that application security is moving in? What are the trends that are driving those moves? And how do we adapt our business to support those needs and to be on the cutting edge and able to support cutting edge customers? So that's a lot of what we're going to talk about today, is what do we see as those trends shaping application security, and what does that mean in terms of innovation drivers or innovation areas, things that need to happen to meet the future needs of organizations and their applications. And the first facet to look at there in terms of trends, I think the words digital transformation had been around well before the pandemic kicked in. But I think we at Veracode have seen our customers really accelerating this notion of digital transformation over the last 18 months. In some cases, that's just been a necessary function of continuing to be able to do business. In other cases, it's been demand driven. So, I mean, you look at someone like Zoom, they went from relatively small number of daily participants to like 200 million daily participants in a period of 3 months. They had to scale enormously quickly, and they had to accommodate a degree of attention that they hadn't previously had, in a way that few organizations ever have to react to. To Zoom has become a verb in the common lexicon. It's not just us geeks and IT folks sitting around talking about it. We look at organizations like Target in the US. Their digital sales grew by almost 200% in the second quarter of 2020, all driven by the sort of external factors. But that all puts pressure on, and it means that they've got to go faster in terms of making their systems capable of supporting that and delivering value and competing in a highly competitive marketplace. And that means that as organizations are going faster, as they're doing more stuff, as they're transforming their businesses to be more digital, more online, the attack surface grows, and it grows pretty much exponentially. Now, whether that's talking about things like in IoT devices, in particular, the graphic I'm showing here is the sort of Nest thermostat device that you might have in your home. And let's not forget that, going back to Target as well, Target were the victim of a breach of, I think it was like 110 million customers. And ultimately, it was their HVAC vendor that led into the breach. That was the entry point that was taken. So, IoT devices, the sort of technology, the sort of blend between hardware and software and connected things, that produces a new part of an attack surface. We also see that the sort of architectural nature of software today is moving more and more API oriented. APIs therefore become the next great attack surface. The proliferation of APIs and available APIs has been extraordinary. Social media, connectivity, talking to people, all of that stuff, great stuff, but actually that also brings in attack surface, whether that's from the risks from social engineering and you know, open source reconnaissance techniques, those kind of things. But also the way that that brings data into your life. All of that adds a huge attack surface as well. And then finally, just software that makes our lives easier. The innocent landing page, all of the stuff that you've built over the years, that can also prove to be an attack surface. One of the stories from when my early times at Veracode is that we had a customer who, by using a service that we provided, they discovered that they still had a website online that was about 4 years old. The website itself was for an event that took place 4 years ago, so it had literally no relevance today. It should have been archived, but it was sat there holding a huge amount of data and was extremely vulnerable to attack. And nobody had thought to retire that application, to take it out of action. So, you know, that attack surface growing, it's partly about new stuff that we're building, but it's also partly about we don't always remember to retire the stuff that we no longer need. So we've got a huge attack surface. And we're also faced with, within that attack surface, a huge amount of stuff that can go wrong. You know, modern single page applications, 43% of all data breaches in the Verizon 2020 data breach report. So, you know, this great new modern world of wonderful fluid technology, fluid applications actually represent a really significant attack vector. And our own research also tells us that open source components, which are used extensively throughout most programming languages and most technologies, they allow you to develop software much more quickly because you're just pulling together pieces of functionality and gluing them with your own code. But actually, 70% of the time, there are vulnerabilities in those components that we see in the applications that we're testing on behalf of customers. So that 70% stat comes from our State of Software Security report. It's an annual report, well worth taking a look at on our website and downloading it. So ultimately, what this means is that there's a huge competitor for most organizations, and it is quite simply time. There's a huge drive for most organizations to get their stuff to market faster in whatever way that is. We've seen organizations honestly being prepared to take the risk of a potential breach in exchange for gaining market share. There was a report, I think by ESG in 2020, and nearly half of development teams actually reported that they have knowingly pushed vulnerable software into production. And the top reasons that were cited for that were pressure to meet release deadlines and also to do with finding vulnerabilities too late in the software development lifecycle. So getting to the point where, look, we've got to launch this software now, we're just going to have to go ahead with the vulnerability anyway. So put these pressures together, speed to market. What it means is that organizations tend to be looking to introduce as much automation as possible into the software development process. And, you know, that's things like DevOps that Craig was referencing earlier. It's all about finding faster ways of doing things and doing them as often as possible. So we don't wait for a monthly release of our software. We push the software to production when it's ready. We just go fast with software development.
And I think, John, just coming back to that earlier statement, you know, we work quite closely with organizations that have used the mainframe for decades, but only in the last 3 to 5 years have really started to integrate it into their automated development capability. You know, they've moved from 2-3 year release cycles to 2-3 week release cycles. And so all of the things that you're stating here are drivers that are native to the cloud environments, but maybe kind of are relatively new risk factors to the mainframe environment that are just being plugged into CI/CD tool chains, with Jenkins at the heart of it, for example. So I think making the awareness to this part of the industry is vital, and ultimately trying to help them with that.
Yeah, absolutely. And look, these are trends. They're not endpoints. So it's come down to 2 to 3 week kind of deployment cycles right now. That will continue to shrink. Things will continue to go faster. This is a direction of travel, and it will continue along that direction until something else comes along. So we can expect to see more of this. So that brings us to what we see as the 3 key trends that are shaping the future of cybersecurity generally, but in particular, the world of software security and application security. The first of those is ubiquitous connectivity. And, we see this in everything that we do, whether you've got a smartwatch, certainly I'm sure you'll have a smartphone, wherever you are in the world, pretty much, you're going to have connectivity and you're going to have the ability to make use of online services. It's part of why the attack surface is growing, because people can be connected anywhere, it allows you to do things that you couldn't previously do. That also means that it's a big part of why risk exists in this environment, because data is flowing between enterprises, customers, applications, cloud-connected SaaS software, all these kind of things. The data is all flowing around because it can. But if we're not looking after that data, and if we're not looking after the software that is managing that data, then we're going to run into problems. The next area is really it's kind of a function of the speed that we're trying to do things today. And that is this idea of abstraction and componentization. Most modern software is being developed in an architecture that is devolved down to the smallest possible unit, smallest possible functional unit that can be made and then reused and deployed in different ways. Obviously, we talked about, or have talked about, open source components a little bit earlier. That's an example of this. But also another example would be sort of microservice and API oriented applications, where we build the little building blocks that supply the back end functionality. And then we worry about how we put a layer of user interface or interaction on top of that. So just the sheer architecture of the way that we're doing things is all very much oriented towards this idea of componentization, making stuff into small functional units that can be reused. And then the third of these drivers, third of these trends is, and I love using this word in a presentation, hyper automation, not just automation, but hyper automation of software delivery. And that's very much this idea of, or it's very much aligned to the idea of DevOps. If there is something that we can automate, then we automate it. Rather than spending time manually doing a task over and over again, it's better to invest a little bit more effort on automating that task such that every time it runs thereafter, it happens automatically. Benefits of that aren't just around speed, they're about repeatability, they're about consistency, they're about ensuring that the way things are done are the way that they're going to be done the next time and the next time and the next time. So these 3 things, we think, are shaping the way that application security specifically and cybersecurity more generally are going to work. So that brings us to the idea of these 4 critical innovation drivers, the 4 critical areas of functionality or technology that are going to have a really big impact on application security in the coming years. So what we'll do, we'll kind of walk through what they are very quickly, and then we'll drill down into each of these in a little bit more detail and look at what the implications of those are for application security in particular. So the 4 areas are cloud native technologies and infrastructure as code. And again, talking to Craig ahead of time on this, I was slightly reserved about whether this was going to be interesting stuff for the mainframe world. And, actually, the more that we talked about it, sure, the cloud native technologies where we're talking purely about public cloud, so perhaps serverless technologies in AWS or whatever. perhaps that is slightly less relevant. But actually, the whole infrastructure as code, what we're seeing is organizations are almost making use of the mainframe as a private cloud environment, using technologies that are virtually indistinguishable from the public cloud technologies, but just deploying them into the mainframe environment. Kubernetes being a really good example of that, where it's definitely a key cloud native or infrastructure as code technology. So there's definitely something to unpack there. The next one was security as code. This is very much aligned to that idea of hyper automation. Really, it's taking things out from user interfaces and pretty buttons and knobs and dials, and actually moving them directly into the code that you're working with and making the validation of them part of the coding process. So we'll go into that in a bit more detail. I think no future looking presentation is complete without mentioning artificial intelligence and machine learning today. And so not just because no presentation would be complete, but because it is clearly a direction that the AppSec industry is going to move in, is this idea of auto remediation. We've long, in the application security industry, we've long been jealous of the kind of things that you can do in a word processor, where if you type a word wrong, you get a little wiggly line underneath it, you right click on it, and you can just select the word that you meant to write. Autocorrect type of functionality. Wouldn't it be great if, as I was writing code for my software, those same wiggly lines would appear and say, oh, I don't think you meant to do that. I think what you meant to say was, let's use a prepared statement rather than just generate a SQL query on the fly. So being able to do that kind of auto remediation, automatic guidance toward fixing things, that would be a wonderful thing, and is absolutely a direction that we're looking towards. So let's just jump forward on me, and then the final one is zero trust models. The issue here is that as we abstract and componentize more and more, we find that each individual component doesn't actually know what's going on in other components. So we can't place trust where it shouldn't be. So we have to move towards software, individual pieces of software having zero trust outside of their own data and functionality boundaries. So we'll drill into all of these in a little bit more detail, starting with cloud native technology and infrastructure as code. What is it? Well, it's a bunch of different things, really. When we look at different public cloud providers, they all have different capabilities that they offer. But fundamentally, it's about saying, well, let's not, as a software developer, worry about how we manage and provision the database. Let's just make use of a native capability of the place where we're going to be deploying this software. It's things like not having to worry about even the servers that you run things on. Let's make use of serverless technology. Let's simply throw a function, a piece of code at an environment, and let that cloud provider take care of the management of it. What it does do is it simplifies the application world dramatically, because there's a load of stuff you don't have to worry about. You almost just have to specify, okay, I need a database. It needs to look a little bit like this. Make sure that's available to me, and I'll make use of it in my code. It also means that we can define what that infrastructure looks like as code, and we can manage it in the same way that we manage our other source code. We can have change control on it. We can roll back when there's a change made that's not helpful. We can have the same kind of approvals process, things like pull requests that we would be doing for our software code. We can apply that to the infrastructure. So what it means is there's a greater focus on the application itself, on the layer of code that we worry about. There's also an implication here that we're seeing a lot more use of containers, because again, it helps us to just be able to drop something into a different environment without having to worry about whether the supporting infrastructure is there. We leave that to the container service itself. There's a lot of benefits, and there's also a lot of benefits in terms of this repeatability model. So every time we deploy, the same structure of infrastructure will be created on our behalf. We don't have to worry about that. It's in the code. That is what's going to get rolled out. Now, from the application security point of view, that's important because it's going to drive some changes to our market. One thing that I hope is going to be a positive change is that cloud-based application security is now very much mainstream. What we see from our on-prem competitors is that they tend to be now deploying to the cloud as well. They're looking to provide software as a service models. And what we see from customers is increasingly requests coming in where there is a stated preference for a software as a service or a cloud-based way of delivering this. We also see that because of the importance of, in particular, containers within this new operating model for software, there's an emerging path for what it means to secure containers. Very much that's about scanning the code before you stick it in the container, scanning the container before you put it out into an environment, and making sure that you have drift control. You have a way of measuring the difference between the containers that are running in production to the ones that should be running in production. So we see lots of talk there around things like immutable infrastructure. Rather than fixing problems in a deployed piece of software, you discard it and deploy a new piece of software, a new container, those kind of things. So path for securing containers is definitely well emerging and moving forward. And another facet here is that, we move from worrying so much about the servers and focus much more on the code itself, the application code, including the infrastructure code. If we're able to just analyze the code, that allows us to apply a repeatable model of analysis as well. So things like static analysis can be brought to bear in that environment too. To kind of drill down a little bit on that idea of focusing on the code. And again, here I'm talking primarily about the sort of more public cloud environments rather than the sort of private cloud on mainframe type of environments. But what we're seeing is that the organization, and particularly corporate IT, tends to focus more and more up the stack. So having to worry less about things like hardware in the network, because those things are natively provided now by cloud providers. Worrying even less about the operating system. Again, the cloud provider or the container will take care of that for you. We start to move up even further, and as we look at things like serverless technology, the components, the app environment, those kind of things become less of a concern for the organization. And really what matters is the application code itself, the weaknesses that could exist there, and making sure that they're being addressed and fixed. So that will free up some time or free up some mind space for the security organization to focus their mind on the application layer. Hopefully that'll lead to more secure software as well. The other thing to mention on this particular point is that the supply chain becomes more important. And we've seen this in the last few months with the executive order that came out from the White House around software supply chain and making sure that you can trust the software that you're using. That's absolutely, we think, going to become the norm. We're expecting to see similar, if not very much identical legislation coming out from Europe, coming out from the UK government, and probably expanding across the world. So why is that important? Well, when we look at older, more legacy software environments, what we do see is that it's largely custom code. Everything that the functionality that is provided is actually stuff that you've written yourself. Whereas as we move forward, what we tend to see is that the custom code forms really quite a small portion of the software itself, with typically around 70 to 80% of the code actually coming from things like open source libraries that we're making use of in our software. We also find ourselves making more use of external APIs, calling out to external systems, that sort of interdependent abstraction and componentization. That's definitely the direction that we see software moving in. And again, that means that our focus needs to change slightly. We still need to test our own custom code, but we also need to be able to make sure that we understand what's going on in the libraries that we're using and in the APIs that we're making sense of. Okay, so that was the first of the innovation drivers. Moving on to the second one, this idea of security as code or compliance as code. Yeah, this is very much moving from user interfaces, moving from pretty buttons and knobs and dials and things to essentially codifying into the software repository the kind of things that we're expecting of this software from a security point of view, and the kind of verifications that we're expecting to make. So that if we're defining those things as part of the software code itself, as we move into a CI pipeline, it's easy to have validation steps in there that take advantage of those defined security as code, compliance as code elements and say, okay, I can see what I need to do. And also I can see whether or not this piece of software passing through the pipeline is actually achieving the standards that are expected of it. So we can actually, abstract away a huge amount of human effort down into fully automated effort that happens in the pipeline. Massive benefits to be had there. One enormous benefit is that it starts to remove friction from the development process. The security organization and the software development organization, I think it's fair to say, have not always been the best of friends. I think it's an inevitable function of the way that security used to work with software development, that it caused friction. Not for nothing are we known often as the department that likes to say no. The security organization's job tended to be, let's do a penetration test or some kind of automated vulnerability analysis of this software. And then we can just throw a huge report over to the software developers effectively saying, your baby is ugly, please make it more beautiful. Do something about these vulnerabilities. That's not a very collaborative relationship, and it caused enormous amounts of problems over the years, ranging from either software being delayed and not actually being released on time because security were blocking it, or from the other point of view, software being released with known vulnerabilities, even though security had identified them because the development organization just overpowered the security organization. The way that we make this better is by finding issues earlier and integrating into the pipeline, making this kind of security as code model work. That's a huge part of that. It means we find things and fix them at the time when an issue was actually introduced. So there's significantly lower cost associated with fixing it, lower rework involved in fixing it. And we then continue to build the next phase of the software on a secure base. So there's enormous benefits to be had from this kind of approach. What does that mean specifically for application security? Well, I think I've touched on most of it. It's very much about moving to a headless model where AppSec is just an integrated tool within the software development process. Manual processes just really get taken away. They either get eliminated completely or they get formalized and managed as a coded process. And security issues tend to get tracked in the code itself, displayed in the code repository, in the pipeline, or even in the defect tracking or issue management or work management software that's being used for planning software. All of that's really good stuff. From the Veracode point of view, there is a negative here. There's a potential negative here, which is that the actual scan engines start to become easier to swap out. They start to become much more commoditized. As long as the engine itself that you choose to use to meet your needs is providing sufficiently high quality results, then pretty much you're going to be able to swap between them fairly easily. I guess that's going to put pressure on us to deliver scanning engines that are better, that produce more accurate results, that do it faster and do it with differentiation of some kind, some way of actually showing that we can be better. And in fact, one of the areas where I think differentiation is going to come is from this idea of auto remediation, or machine learning and automatic remediation. And what we're looking at here is the application security technology, not just finding an issue in your software and telling you you've got a bug, but saying you've got a bug and here is the code change you need to make in order to fix it. Now, you could argue we already sort of do that. We certainly provide guidance with any issues that we report, guidance on the kind of steps that you need to take in order to fix them. However, this is going further. This is actually modifying the code on your behalf, creating a pull request with modified code in it that is going to completely eliminate a security vulnerability from your software. And that's fantastic. You know, time spent on fixing vulnerabilities gets eliminated. It's just about clicking the button that says, yes, I accept this fix. The automation also decreases friction. It makes it easier for the security and the development organization to be friends, and that has its own benefits. So overall, I think this is going to be a massively important thing. What it means for AppSec, well, it's going to become, I think, one of the key battlegrounds between different application security vendors. Our ability to provide good fix recommendations that work and that don't introduce other issues into your software is going to be a key part of being a successful AppSec vendor in the future. So then the final of the innovation drivers was around the zero trust model. Now, what we've seen over the last decade really is that the firewall has started to dissolve a little bit, and infrastructure and software have moved out beyond it. Whether that's your own software moving beyond, or you're making use of software that lives beyond there. Trust is no longer the default that you can make. So you have to assume that that anything that you're making use of could be malicious and needs to be validated at every step of the way. It also is driven by the sort of componentization that we were talking about earlier. And what we see as a result of this is that it's placing a huge burden on security teams. They're kind of overwhelmed by the amount of stuff that they've got to manage, they've got to validate, and they've got to make sense of. So what it means for AppSec, well, you can't trust things to be secure by design, because each individual component has to be effectively isolated until there's a level of trust that's been achieved, until you've been able to demonstrate that things are as secure as they should be. It also means that we're going to find greater burden on ourselves, not just to secure our own software, but to validate the security of external software and external services that we're making use of. So again, the burden on the security organization is only going to increase as a result of this, which is a slightly negative note to end this particular section of the presentation on. But you know, this is a big part of what's going to be challenging for security teams in the future. So the final thing that I wanted to touch on, and I'm conscious that in GSE, we're not looking to do any kind of pitching. We're not like trying to sell to you. However, I'd be remiss if I didn't at least help you understand who Veracode are and how we might be able to help if you're facing any of these challenges or looking at any of these things at the moment. So I'll start off with what we do. And really what we do is a combination of three things. We have application analysis technologies, all well suited and well able to be integrated into automated software delivery processes. We have our static, our dynamic, and our software composition analysis technologies, All very good, all very powerful, really helpful for finding issues. We also focus heavily on actually helping our customers to fix the problems that are found. There's the saying, you don't make a pig fatter by weighing it. Similarly, you don't make an organization more secure just by finding vulnerabilities. You only become more secure by fixing those vulnerabilities. So focusing on how we can help the developers to fix them and how we can help them avoid reintroducing issues in the future is really important to us. And then the final part of that is the sort of governance side of things, because whilst we can focus as much as we like on dealing with the software development process, organizations don't operate within a vacuum. They operate within typically regulatory environments that are going to constrain what they do and how they do it, and are going to make requirements upon them to be able to demonstrate that they are achieving the things that are being asked of them. So the governance side of things, setting out what the goals are, helping to scale that program through the use of best practices and being able to sell and demonstrate the value of what you're doing in your application security process. That's a huge part of how we help. Now, I'm conscious that I've kind of taken a little bit longer over these slides than I originally intended. There are a couple more slides which drill down into each of these areas in a bit more detail. But I think probably for the best would be if we skip over those and let's have a look and see what questions have come up in the chat.
So, John, I think we've managed to kind of knock some of the questions off as we've gone. So we've had some input from Atul and Kerry and what have you. I think we've done that. We've focused on around the open sourceness. I'm just wondering, John, whether it might be worthwhile just looking at slide 26, the one there that talks about building security into the phases of the pipeline. As we've seen in GSE in the last few years, building pipelines has been prevalent in the mainframe space. And I think this really, again, without going into too much detail, starts to identify the different pieces of code that we can actually help identify as potential risk vectors, and then what to do to remediate that. I think that'd be worthwhile just talking through that one.
Yeah, absolutely. And it's this is a key part of how to do AppSec well in the modern era, because it recognizes that there are kind of different constituents to the AppSec process. When we think about an individual developer operating in their IDE or Emacs or whatever, and they're making changes to software, there's a level of testing that would be valuable to them. And the kind of level of testing I'm talking about here are typically our IDE scan technology. This is just scanning small sections of the code to provide insight into security issues. Also, open source software composition analysis fits in quite well here. The key thing about this is we need that feedback to be virtually instant, because you can't slow up an individual contributor's work by having them start running a scan and then wait for 10 minutes for some results to come back. 10 minutes is pretty fast to do the kind of stuff that we have to do to identify security issues in software, but it's pretty slow if you're the person who's in the middle of writing some code and you're having to wait for that to happen. So there are things that we can do on that left-hand side in what we term the sort of my code environment, where we're helping, and that's around static and SCA. As we move forward through or into the pipeline, particularly the CI side of the pipeline, well, we've got a little bit more latitude on time. People still don't want their pipelines to be held up for 20 minutes, an hour, waiting for scans to complete. But if we can get results out within a couple of minutes, this is a really good time to start doing security testing, mainly because it's that point where everything comes together and it's no longer my individual code, it's about all of our contributions coming together. That's continuous integration in a nutshell, really. So at that stage in the process, we can look at doing slightly more in-depth. Certainly static analysis fits in well here, software composition analysis. There's an emerging technology for us, which is interactive application security testing, IAST, where we actually deploy the software and run tests against it. That's also potentially applicable to this kind of environment, because it would be triggered by the automated testing processes that you might already have in place for your software. And then as we move through to the production end of things, to continuous deployment, this is where we need to start being able to make informed decisions about whether or not we can promote a particular build from staging through to production. It's where we need to be able to have reporting that feeds back to the organization and says, this is what's running in production, and it is or is not compliant with the standards that we've set for it, the level of security that we've set for it. So this is really where we move from sort of more pipeline level scanning to what we would term policy level scans, scans that are reported against for compliance purposes, and that provide the greatest level of depth that we can in terms of analysis and in terms of reporting. So again, static and SCA fit in well here. Dynamic analysis fits in well here, because we're now deployed into a production environment. We can test that production environment dynamically and test that its behavior is as it should be. And all of this, we want to make sure that we are getting that central reporting. We're getting the visibility of the results that allows the governance side of an application security program to work. It allows us to be able to report at a corporate level whether or not we're meeting the requirements that we've set for ourselves. So really, that's that continuum, really, ranging from individuals working on their own code through to deployed versions of software into production where all of our code has come together.
Cool. Thank you. I think it's good to just articulate those different stages. And I guess probably just one last question coming on the chat. So are there scanning agents available that run on z/OS, or does the source code need to be exported?
Yeah, so because we're software as a service, we don't do any of our scanning on our customers' target infrastructure. In every case, the code comes to us, we do our analysis, and we provide results back. So sadly, that means the answer has to be a no. There is no agent for Z. The code does actually have to come out and be sent to us.
And it's that decades of information that we've got available at our fingertips that enables us to provide that industry awareness as to what good looks like, and kind of a feature as people move more and more to a cloud first mentality as well. So I can't see any more questions in there. Stuart, I'm not sure if you've got any more at your fingertips, or anybody else that wanted to raise anything before we give some time back.
No, that was very, very interesting, thought-provoking. For feedback, the session is, thank you, 4BB, and the link to the feedback form is in the chat. But I really enjoyed that. You know, I know it was a bit of a dabble into potentially not bog standard GSE app dev track, but appreciative of your time, gentlemen. That I think a lot of this stuff is going to become more prevalent. Sometimes you have to talk about things before it becomes a thing. So looking forward to the direction that mainframe AppSec takes.
Yeah, and I do believe, Stuart, that having spent time in the mainframe world and outside of the mainframe world, and knowing that platforms like Kubernetes and OpenShift are going to be kind of smashing together, then some of these things that straddle the lines, I think are going to be, you know, those lines are going to be blurred a little. And I'm hoping that John and I will be invited back next year, you know, face to face, to do this over a bar rather than a Zoom call, and talk about some of the the customer experiences we have over the next coming year. But also we already do have mainframe customers that are exploiting this capability today that are financial services regulated organizations. So we can absolutely talk about those on a one-to-one basis as well.
Well, if that's the entry criteria for you being invited to come and talk next year, that you're going to be buying the beers, you're in. Okay.
There we go.
So thank you very much, John. Thank you, Craig. I'll let you know where the recording is when it's released, so you might be able to use this session elsewhere. But thank you very much for your time, and to everyone else, have a good GSE. Thank you.
Cheers, guys.
Thank you.